here I took sort of a convenient example or an easy example, if you may say. In this one, the reason I'm saying it's an easy example is because there are only two factors, so you can easily do it with any of the methods independently. But a lot of the times what you will really be doing is you will be probably doing a mix of two or even maybe three methods, right? So you combine these methods conveniently in order to find the unknown. So this was the first type in which you have linear factors. If you have linear factors, then your structure would be such that the denominator also has linear factors. Let's move on to the second type, and that is if we have repeated factors. So if you have something like px plus q divided by, so this is the second, this is the second one, px plus q divided by, let's say, ax plus b, but this is squared. So in this case, what you would have is some number divided by that factor plus another number divided by the square of that factor. So let's say 2x minus 11 over x minus 4 whole square. I know that this should equal a over x minus 4 plus b over x minus 4 whole square. Let's cross multiply. So 2, or if you may say multiply both sides, 2x minus 11 is equal to a times x minus 4 plus b. Right? Now I can see that we can conveniently use the fact that when x is equal to 4, 2 times 4 minus 11 is equal to, well, this would become 0, b. So b, in other words, is equal to 8 minus 11, which is minus 3. And then we can argue that, let's say, when x is equal to 5, so now I'm following the second method. This would be 10 minus 11, this would be equal to a plus b, which now we know is minus 3, so we can replace this. So minus 1 is a minus 3, in other words, a is equal to 2. Right, and another method that again we can conveniently use is 2x minus 11 is ax minus 4, and b we know is minus 3. So we can compare a to x, so a would be directly 2. Right, so this is the second type, that whenever you have repeated roots, this is the structure that follows out. And I must mention here that, let's say, if I had something like, if I go back to my first type and add a linear factor over here, let's say cx plus b, then you would simply add the way you usually do. So this would be plus c over cx plus b, right? So over here I gave you the roots actually, but let's say you have something like px plus q, and then in the denominator you have some quadratic factor that is not reducible, so it cannot be reduced to its linear factors. So something like px plus q divided by, let's say, a linear factor ax plus b, and then a factor which cannot be further reduced, cx squared plus dx plus e. So this is a quadratic. Now in this case, well, first of all, let's handle something we've already done before. So this would be a over ax plus b. Now for the factor, the quadratic that is not reducible, this would be some number x plus another number divided by that quadratic, so cx squared plus dx plus e. Right, so this is a linear and this is a quadratic, right? So let's try an example from the book, that is 8 plus 2x minus x squared divided by x minus 1 x squared plus 2. So we know that this should equal, well, some number over x minus 1 plus some linear combination bx plus c divided by x squared plus 2, that quadratic. Let's cross multiply. So 8 minus 2x, 8 plus 2x minus x squared should equal a times x squared plus 2 plus bx plus c times x minus 1. Right, so I can notice that if we input, let's say, if we input when x is equal to 1, I know that when x is equal to 1, this will cancel out, so it will make my job a whole lot easier, because now I can get a. So 8 plus 2 minus 1 should equal a times 3 and then plus 0. So this would be 9 equals 3a, in other words, a equals 3. So great, we know the first unknown. now what I'm thinking of doing is I can expand and then compare coefficients. So, well, I can notice here that 2a plus minus c will give us 8, but let me expand it whole out so that you can see it clearly. So this should equal ax squared plus 2a plus bx squared minus bx plus cx minus c. So let's group this. So a plus b x squared and then minus bx, sorry, this should be plus b minus c x, so both of these, plus 2a minus c, right? So this is equal to minus x squared plus 2x plus 8. So in other words, a plus b must equal minus 1. A is 3, so b must be minus 4. And then we can also see that 2a minus c must equal 8. This is 6. C would turn out to be negative 2. Sorry, this should be c minus b, right, because this positive is negative, right? And then just to assure, just so that you're sure, or to recheck rather, you can also see that c is minus 2, minus b would be plus 4, plus 4, this would give us 2, and that's correct, right? So one thing to notice here, that in all of these three types we can notice that that the degree of the denominator has always been greater than the degree of the numerator. Just to recap, degree is basically in any polynomial, the degree is the highest power of x. So if I take a linear factor ax plus b, this is degree 1. If I take a quadratic, that's degree 2, right? So in all of these cases, the degree of the denominator has always been greater than the degree of the numerator. Like, so it's similar to saying that it has always been something like a over b, where a is less than b, right? So this is a proper fraction. In other words, let's say I tell you something like 11 over 5. We call this an improper fraction because, well, the numerator is greater, so you can split it up into 2 multiplied with 2 plus 1 over 5. So case 4 are improper fractions in which the degree of the numerator is equal to the degree of the denominator, at least for our syllabus. For the formal definition, the degree of any time the degree of the numerator is greater than or equal to the degree of the denominator, it is an improper fraction. So something like, let's say ax squared plus bx plus c divided by px squared plus qx plus r. They're both quadratic. The degree of both of them is 2. So the way this would turn out to be would be that since their degrees are the same, there would be some number a plus b over the first factor and c over the second factor. Or if this is not reducible, then you would follow the usual. So the important thing to note is that there would be a number with the denominator 1, if you want to think of it that way. So let's do an example from the book, that is 2x squared plus 5x minus 11 divided by x squared plus 2x minus 3. Now, one thing you can do is you can definitely do long division, and that would give you the a. But instead what I'm going to do is I'm going to say that this equals a plus, okay, so what are the factors of x squared plus 2x minus 3? We can middle term break, it would be x plus 3 multiplied with x minus 1, right? So we know that this would be b over x plus 3 plus c over x minus 1. Let me erase this, right? So let's cross multiply. 2x squared plus 5x minus 11 is equal to a, and I'm actually going to write these in factors simply because it's more convenient, plus b times x minus 1 plus c times x plus 3. Now again, I can notice here that I can conveniently use the cover up method, that when x is equal to 1, this would be 0, this would also be 0, we're only left with c. So 2 plus 5 minus 11 is equal to 4c, minus 4 equals 4c, c equals minus 1. And then similarly, when x is equal to, let's say, minus 3, a would be 0, but now c would be 0 and b would be something. So 2 times 9 minus 15 minus 11 is equal to negative 4b. This would be negative 8 and this should equal minus 4b. In other words, b is equal to 2. And we are done. The final answer would be, wait, no, we're not done. We're left with a. For a, we can do a couple of things. What we can do is, well, one thing you can notice is that when you expand a x plus 3 x minus 1, a x square, well, actually we can copy the original one, x square plus 2x minus 3, ax squared plus 2ax minus 3a. You can observe that you can actually go ahead and expand the whole thing, but you can see that ax squared is the only x squared term, and here the x squared term has the value 2, so a should equal 2. What you can also do is you can take some random value, let's say x equals 0. So minus 11 is equal to a times 3 multiplied with minus 1 plus b, which we know is 2 times minus 1, plus c, which we know is minus 1 times 3. So minus 11 is equal to minus a minus 2 minus 3. A is equal to 11 minus 2 minus 3. Sorry, this would be 3. So 3a is equal to 6, a is equal to 2, and we're left with the same answer. Right, so that pretty much covers up partial fractions. These are the 4 types that the A2 syllabus requires, and it's really just some algebra. You can get a hang of it after some practice. Right, see you next time.